Hey everyone, I'm Ohad. I'm a product manager at Starkware for the last few years, worked a lot on StarkNet. And today I want to talk with you about Volition and why it's a game-changing feature that would push the limits out and even cheaper layer 2s. So first we're going to cover briefly what is StarkNet, and what it is, and then we'll dive right into Volition, which is a feature that comes to StarkNet soon. Basically discuss why it's a game changer and what's so novel about it. And then I'll end the talk with inviting you to see how you can use this feature with some examples. So StarkNet is a permissionless validity rollup layer 2. It's launched on mainnet on November 2021. It's actually been the first general purpose ZK rollup to be on Ethereum mainnet. And since then, we've passed quite a long road. We see many attention from a lot of very talented developers. And today we have on StarkNet a few hundred projects with more than 1,000 repositories in Cairo, which is a new language we invented for StarkNet to be as efficient as possible. And more than $100 million invested in startups in the StarkNet space. So really booming developer community, and we're already starting to see quite a lot of traction on our mainnet. With 13 million transactions and almost 1.5 million contracts deployed on mainnet to date. And you can see the vast diversity in our ecosystem. Basically, we have developers that are coming for DeFi. We have several dozens of projects. And for NFT and for gaming, and even for projects that are not usually used to be on L1, such as complex voting system, decentralized identity, really a wide variety. And the reason so many projects are keen to come to StarkNet is basically due to the promise of a validity rollup, right? Because what do? How all of this magic work? We basically tell users, OK, you want to trade with scale, right? But also don't to give up on a term level of security. So users are doing a lot of work on StarkNet, right? Basically, all the transactions are happening off-chain. And we then prove very succinctly and very efficiently that all of those transactions actually happened correctly. And this way, anyone that runs an Ethereum full node has, as one of its smart contracts, a StarkNet verifier. Essentially, he verifies the entire StarkNet transactions happened as they should be. This means that, if I have, say, 2,000 ETH and I move some ETH to one of you, then, Ethereum doesn't need to know about it, right? All of Ethereum is doing is verifying a proof that indeed I signed the transaction, indeed I have the balance, and so on and so forth, right? So no one really can take my money. It's verified by Ethereum. And our proofs are really scaled, like 100 or 1,000x cheaper to verify than to execute. So this is how StarkNet works. This is the promise, but something is missing here because you can quickly go to a site called L2 Fees that currently shows the fees on various L2 platforms and Ethereum, and StarkNet is included here. And you can see that although that I claim that our proof generation is like 100,000x cheaper, de facto, currently we are 10x cheaper than Ethereum, and we are no different than any other layer 2 that is general purpose L2, for example, Loopring or not. So what's the gap here, right? Why we have such efficient proofs? Or for example, you have your optimistic rollups that don't even have proofs at all. And the gap is only 10x and not much more. And the reason is that I, hidden some extra parts that we pay, and actually we pay a lot on, and this is data availability. So it's not enough to pay to say to Ethereum, look, Ohad sent this transfer, and this transfer is accurate. We need to also tell Ethereum, look, the new balance of Ohad is, now it's 1,000 ETH. Why do we do it, right? Why do we say with each and every proof that comes to Ethereum that basically all the new state? We do it because if you use StarkNet, you want to assume only a term level of security, right? You don't want to assume that the StarkNet sequencer would continue to work. You don't want to assume that the full node would continue to work, right? You want to say, OK, this is the StarkNet state, and I'm fully aware of it, right? And I can work with it, and I can continue and advance my state on my own, right? So I can withdraw my money, right? Because if we prove that all the transactions are correct, but in the end I have their money and I cannot withdraw it because the sequencer is frozen, then it's not enough, right? We need to tell Ethereum basically all the data. And so, if we go from the other direction, if you don't know the data, it means that you essentially trust the sequencer to continue to be operating, because if it would not, you don't know the data, you don't know how to advance the state, essentially your funds are stuck. It doesn't mean that someone can steal them, but they're still stuck. Not a very good situation to be in. Notice that with validity rollup, this is the sole role of data availability, just to ensure the system is not frozen. For optimistic rollups, it also has to do with the correctness. And data availability is damn expensive. As you probably know, it costs 16 gas to tell on Ethereum 1 byte, meaning that it costs a bit more than 500 gas to update Ethereum in a UIN256. Now, most use cases involve more than one UIN256 to report on, right? Even a simple transfer, my balance is updated, the recipient's balance is updated. Ethereum also needs to know not only the new balances, but like who is transferring to whom money, right? So it's multiple UIN256 to report on, right? So you can already see that even for the simplest of transactions, we pay thousands of gas for data availability. And currently on Starknet, data availability is more than 90% of the cost, right? The proof, like the things that people say, oh, it's complicated, it's less than 10%. So this is the current situation that we are in, right? We are like forced to tell Ethereum all of this data because we want to be secure, but still we pay heavy price for it. So I want to challenge those assumptions because like until now, I said, okay, we must have data availability because what if the state is frozen? We'll need to know what it is, right? It's crucial to ensure all users have access to all of their possessions. But it might not only be the case, right? Let's see what different users would like to have. If we take that most trivial example, right? If we have very, very cheap NFTs, right? We want to have a game with NFTs that cost as low as 1 cent. It doesn't make sense currently to buy those NFTs not only on Starknet, but like on any layer too, because just to update on Ethereum, hey, look, there's been a transaction. I received a new NFT. It would cost much more than the cost of this NFT, right? So it's to be expected that users that want to buy one set NFT would say, you know what? I just want this NFT on the network. I'm okay with having a bit weaker security assumptions that like if some crisis happened, my NFT would be unavailable. I'm okay with that. I want my NFT and I want it cheap, right? And we can see a very similar phenomenon that can occur inside each and every transaction. Because let's assume I now buy an expensive NFT, right? I would like the information that I have this NFT to be backed by Ethereum. And probably the person that sold me this NFT would like its very much increased balance to also be backed by Ethereum data availability. But another thing that happens in each and every transaction is fee payment, right? I pay a few cents to the sequencer, potentially from like a small expenditure account with only a few dollars in it, right? That I expect will be able to fund many, many transactions going forward, right? And maybe I want to say, okay, I want the fee payment component to be processed much more cheaply. And I'm okay with losing $4 if some crises happen, right? Because on the bright side, I earn much, much cheaper transactions on each and every transaction. So there are many use cases where data availability on Ethereum might be an overkill, right? And might be a deterrent for the economical efficiency of the system. But I think that for some other use cases, and this is a really thing that was surprising to me, giving up on Ethereum-backed data availability actually makes no security compromise at all. For example, let's look on Oracle price reporting. Okay, I have an Oracle that updates the price of Bitcoin, and it does it, say, 3 times a second, right? And those updates are all independent of one another, right? In like few hundred milliseconds, a new update would come. If I go back to the motivation of why to have data availability, right, we say, okay, the state is frozen for a long time. Everyone would need to know what the state is. Assume we just lose access, right, to what the Oracle price reporting was. It doesn't really matter, right? We can tell this Oracle, okay, please let us know again the price, right, ideally, and we'll be good to go, right? There is no need to continuously pay in like high frequency in each and every transaction this extra cost of backing your data on Ethereum. And you can see similar thing that again happens in each and every transaction with nonce, right? Why would I need to tell Ethereum what the nonce of my account is? Does anyone care if its account nonce is like 1 or 200, as long as it doesn't have a long series of transactions that is now seeing, okay, which are being processed? So like with oracles, we can work with nonces that are not backed by Ethereum data availability, right? And we can progress them continuously, right, in ways that only Starknet knows what the nonce is, right? And people can send transactions continuously on the network. And then, something bad happened, the entire database collapsed, we no longer have access to this data. We can always revert to a second track, right, of on-chain nonce. And now we can say, okay, we continue to send transactions to the network, but now we just use a second nonce. So to go back a second, right, we've seen why we need on-chain data availability, right, as a network. Obviously, it's crucial to have a Ethereum level of security when you're dealing with a large amount of funds or NFTs that worth a lot of money. But we also seen multiple reasoning for why this is an overkill, right? We've seen examples where making Ethereum-backed data availability doesn't make sense. Doesn't make sense from an economical standpoint, and we've seen cases where it actually doesn't help at all, right? And users are just paying for nothing. And one way to approach it is to say, let's make data availability cheaper, so it would be less of a burden across the board. And Ethereum obviously mines a layer 2 solution, so it's go forward with an EIP called 4844. Basically, what is Ethereum Improvement Proposal offers is to have additional data blobs that are attached to each and every block. And those data blobs will be only used for a data availability solution, and they're expected to be much, much cheaper. And the reason we want to do something better and are not satisfied with this solution are 2 points. First, it's unknown how much help it would actually be, right? Because if data availability becomes cheaper, suddenly you'll have much more layer 2 activity because it's cheaper, and then those blobs would fill up, and essentially you'll return to the same price. Or there is no inherent reduction fee here that we can count on in the long term. But I think the even stronger point is that you really want different levels of security for different actions you do on the network, right? If I now trade $1 billion, maybe I would say, okay, I'm not satisfied with these data blobs. I just want my data to be on the block as it is now. And if I trade 2 cents, then maybe even a 10x reduction that 4844 would maybe bring me is not enough. So we want to do something more flexible, and we'll introduce Volition to Starknet within a few months. Basically, Volition means that if you are now write smart contracts, you can decide what parts of the smart contract would be backed by Ethereum data availability, and which parts of your smart contract would be backed only in the Starknet sequencers and full node level. And you can even have multiple variables within the same smart contract that refer to different data availability solution, right? Like maximal flexibility. And the novelty of this approach is that if, for example, some data availability crises happen, right? All of those guys that counted on Starknet level of data availability got screwed. If you are using Starknet, but you always had Ethereum level data availability across your application, you are unaffected. So like HappyFlow, you can interact seamlessly with those parts that are Starknet backed data availability. But if you want evacuation that is not dependent on that, sure, go ahead, right? We don't hurt your security assumptions for trading $1 billion just because we added some features to those who trade cheap. So I'm going to dive even a bit deeper and explore with you exactly how it would work. Those are just 2 slides. I think it would make everything a bit more precise and coherent. Just keep the intuition in mind that we basically allow the full flexibility of solution, right? So you do something cheap, you can do it much, much cheaply without paying on data availability. You want to do something expensive, go ahead, you're unaffected. Basically, starting version 0.13 that we plan to have on Q3, Starknet would have two state trees. We'll have a tree with L1 data availability and another tree, the left tree, with L2 data availability. And whatever change happening on the right tree, we will continue to update Ethereum, right? So if you listen to Ethereum, you can know whatever happens in this, right? Even the smallest thing, you can fully reconstruct this tree and can fully operate with it. And the left tree, we don't tell anything of what happens to Starknet to Ethereum, right? We basically just tell the root. And if you are now write smart contract, in the variable level, you can decide, OK, I want this variable to be in the right tree and this variable to be in the left tree. So you have maximal flexibility, but also minimum impact, right? Because if this left tree is to go to west, right? Someone bad comes, throw it away. You can continue to work with this tree, right? You can continue to read and write variables from them. You can potentially continue to operate seamlessly. All of your code would still work, and you are totally unaware that some data availability crisis happened to some other part of the network. So this is the design we have. Obviously, it puts more flexibility, but also more responsibility on the developers, right? Is it even make sense to use this design? How we envision things would work. So let's look at a concrete example, right? Like I call it the ERC20 of tomorrow. Because basically, if you think what ERC20 is all about, we really want this ERC20 to hold the large balances in as secure manner as possible, right? But if you're using this ERC20 to just transfer like a few cents, right, or a bit of fee, maybe it doesn't make sense to pay as much. So what happens basically, let's look on like hypothetical ERC20, say USDC on Starknet. So people from the outside can still call it the USDC contract, right? It has the transfer and balance off and all the methods we know and love. But internally, it does something very, very interesting. It's basically say, OK, I have a certain set of users and smart contracts and applications that want their data to be in the left tree, right? In the L2 backed data availability tree. And we have another set of users and applications that want their data to be as secure as possible, and they chose it to have in the L1 backed tree. And each and every user or smart contract can go to this USDC contract and tell him, look, I want my balance to be only available in the L2, or I want my balance to be available in Ethereum data availability. And when someone calls to this smart contract and tell him, I want to transfer funds, like with a sender and a receiver, the smart contract would say, OK, what is the data availability method of the guy that is about to send money, in this case off-chain, and what is the data availability method of the, in this example, contract that is to receive money, right? And this way it knows basically which variables to access, right? Which trees to update in a way that is corresponding to the transfer that is happening, right? But all the people outside this contract can be unaware, right? They can use this ERC20 with the same interface they are used to. They don't need to care about the fact that actually much of the operations has become cheaper, right, due to rational decisions that some of the users in the network made. And this is like the situation that would be in Starknet 0.13, as I just now presented it. Basically, we'll start with two trees. One is Ethereum-backed data availability, and the other that we currently plan to be like 10x cheaper when it comes to updating the data would be L2-backed data availability. Going forward, however, this spectrum should be much, much more refined, right? Because like Ethereum-backed data availability is the most costly and most secure option, and Starknet-only data availability is like the cheapest and the most insecure option, right? Because basically you gain it whatever data availability you choose. And going forward, we'll add more data availability methods. You can envision like a committee, right? Persons that say, OK, I don't want my data to be on Ethereum, but I still trust, say, Google to sign on my data. And if Google signs on my data, I feel it's good enough. I have it covered, right? And obviously, getting signature from Google can be much cheaper than posting this data on Ethereum, right? Other people could say, oh, we want Starknet to integrate with data availability solutions. right? Or other platforms that are there to storage stuff, or like Celestia, like Filecoin. So maybe we'll do some integration with them, right? To add basically people and developers more choice for where is the data that they care about in their application is stored versus how much it costs to use this solution. And if I'm allowed to zoom out a bit beyond just Volition, I think that our approach here really reflects the StarkNet approach. Namely, we want to allow developers as flexible choices as possible and to be as powerful as possible and see with much joy, if may I add, what are they doing with all this power. For example, account abstraction, which there is a full talk about it in Vidal-Asia, but I just want to briefly touch on it, is another feature with similar spirit. Basically, we say no need for developers to always assume that the nonce is incremental in a certain way. The signature verification is the same. We want to have account abstraction as a first-class citizen, right? We want to offer developers full flexibility how transactions are verified. What does it mean that the transaction is valid? What is the nonce management, and so on. And we had a hunch that adding this flexibility may be a good idea, and we have several things in mind, just like the RC20 I just presented. We have similar first naive ideas for account abstraction. But we couldn't have imagined that there would be projects and startups that take this concept and authenticate users with their fingerprints as a phone wallet, right? Which is something you just can't do on Ethereum today. So I'm excited because this is the new feature that would again pave the way to new frontier of flexibility from the developer side. And I want to see basically what you can do with all this flexibility and what trade-offs would you explore, and how can we help you to build the most scaled and secure application with StarkNet. You can view here Tweet, Discord, and Docs. Thank you. Questions? Yes.
So first,
Hi.
sounds super cool. I guess maybe, I didn't read the paper Volition or anything, but it sounds like I'm struggling to see how it's not problematic when you have composability.
Mm-hmm.
For example, if there is a contract out there pre-existing that expects some sort of stake in another contract to always be available, and it doesn't know about Volition, maybe it's an old contract, right? So I'm assuming that this is backward.
So first of all, it's backward compatible because if you don't state explicitly what you use, you're going to continue to use on-chain data availability. So that's a great question, right? You are right that, with composability, you also assume that the contract you're using works, right? So if you are using Ethereum-backed data availability and you, as a dependency, use another contract that isn't, then it's okay, everything would work. You just need to, be aware to whatever external calls you're making to external contract could break, right? So you need to carefully design everything. Our mindset is to encourage patterns that basically let users choose on each and every level, right? Do you want to use on-chain data availability? Do you want off-chain data availability, which is much cheaper, right? And then applications could be built in such a way, and even without liquidity fragmentation, right? Because it's the same contract, that basically allow users to choose. And thus, users that would feel more comfortable would just have cheaper transactions.
If I'm a very high stakes contract that already exists, there is another contract that I interact with and I depend on it that has upgradability. It upgrades to a lower DA level, and suddenly that data is not available. And I am a contract that...
So you're correct, but if you're dependent on an external contract with upgradability, tons of things could break unrelated to this, right? You essentially trust their developers to always make mindful decisions, right, and always to not break anything, and this is no exception. Any other question? Okay, thanks.